All right, welcome. Let's take out our lesson 4 packet, and what I'd like you to do is turn to this page over here. And what we're gonna do is, yesterday we found out how to find like sine of 45, cosine 45, sine of 60, cosine of 60. We did this section here. Now we need to learn something a little bit different. So here, let's take a look at this. It says, suppose P is the point on the unit circle obtained by rotating the initial ray, this initial ray, 150 degrees, okay? It says find sine of 150 and what is cosine of 150. Okie dokie, so what do? Remember, if this is the initial ray, it never moves, it's right here. If we rotate this initial ray, we make 150 degree angle. And just remember that if this is 0 degrees, right? Because remember the sun starts here, this is 90 degrees, this is 180 degrees, and this is 270 degrees. Where would 150 degrees be? It will be between the 90 and the 180. It'll be something over here. So our terminal ray that we're going to create will be something like this. And what will it make? It makes a 150 degree angle. Now that we have that, the question is, how do we find sine of 150 and cosine of 150? And now here, yesterday's notes, these will help, okay? So steps for calculating sine of theta and cosine of theta of angles greater than 90 degrees. Here, this 150 is greater than the 90. So let's follow the steps. It says step 1. Put a point on the intersection of the terminal ray and the unit circle. So here, if this is the terminal ray, right? Remember, this is the initial ray, this is the terminal ray. Put a point on the terminal ray that intersects the circle. So it'll be right here. So we put a point over here. Step 2, it says drop a perpendicular line from that point down or up to the x-axis. So here we take this point and we go down or up to the x-axis, right? And now here, notice, what did we create? We created a triangle, right? Let's examine this very closely. We created a triangle. Notice that this angle has to be 90 degrees, right? And can we calculate other parts of this triangle? Well, let's see. Here it says using algebra, calculate the reference angle. So the reference angle is a definition that I have on the board for you, but I also have it here on my phone. So let's say if this is our angle, right? This is the initial ray, and this is the terminal ray. Here, if this is theta, this phi, this symbol phi, represents the acute angle between the terminal ray and the x-axis. So what this is saying is that this angle that we created over here, which we'll mark as phi, right? This will be phi. This phi will be the reference angle. And can we calculate this reference angle? Absolutely, because remember that if we have a line, what do we know about a line? It has 180 degree rotation. So that if this is, oops, sorry, bad diagram. If this is 150 degrees, right? If here to here is 150 degrees, then this angle over here has to be 30 degrees to match the 180. So this is 30 degrees, and this is 90 degrees, and this is 60 degrees. And notice, which triangle did we create? We created the 30, 60, 90 triangle, right? If this is 30, this is 90, and this is 60, we created this triangle. And notice that on the picture that this is a half, and this is square root of 3 over 2, and this is 1. So if we find sine of 150, we're basically taking sine of 130. I'm sorry, not 130. It's basically sine of 30. So watch. What is our opposite over hypotenuse? It's just 1/2. And the question we have to ask is, this 1/2, is it positive or negative? And the answer is it has to be positive. Remember, because everything above this x-axis is positive height. This is negative height, okay? And what about, so this sine of 150 is equal to 1/2, and cosine of 150 will be what? It'll be adjacent, this is square root of 3 over 2. It's adjacent over hypotenuse, right? This is adjacent over the hypotenuse. But the thing we need to see is, remember the co-height. Co-height. Is this positive or negative? And this will be negative. Because remember, co-height on the left side is negative, co-height on the right side is positive. Height positive is up, height negative is down. Remember, it has to do with the xy axis. Remember, this is negative x, right? I'm sorry, this is positive x. This is negative x. This is positive y, and that's negative y. It has to do the same thing with this idea. So the cosine of 150 is negative square root of 3 over 2. Okay, it's not positive. We use that 30-degree angle to help us calculate this measurement. Okay? If you feel lost and confused of what happened here with the positive and negatives, just let me know. So let's discuss this real quick. That if we're here in quadrant 1, our sine of theta, you see, remember, quadrant 1, quadrant 2, quadrant 3, quadrant 4, our sine of theta, I want you to think about it, and cosine of theta, degrees, will this be positive or negative? All right, I want you to think about that for all of them. Our sine of theta, if it's over here in this quadrant, will it be positive or negative? If I put cosine of theta, will it be positive or negative? And I want you to do that for every quadrant. Okay, so cosine theta, right? Sine of theta, cosine theta, and figure it out. Is it positive or negative? So I'm going to pause the video and then write out the solution. Here, our sine of theta will be positive, our cosine theta will be positive. Sine of theta is positive, cosine of theta is negative. Because remember, if you're above, your sine of theta is positive. If you're to the right, your cosine theta is positive. If you're to the left, your cosine theta is negative. And if you're below, your sine theta is negative. Okie dokie. If you feel lost and confused over here, please let me know. What I'd like you to do is the same thing we did for this question here. Try and follow the steps, go on the board, and calculate sine and cosine of 120 degrees. What do you get? What will be sine and cosine of 240 degrees? What will you get? Okay, and for the next one, try and do sine and cosine of 330 degrees. Okay, follow these notes. You can do it. I believe in you. I'll see you.